AI just broke cybersecurity forever. Anthropic's Claude Mythos just hit 74% on SWE-Bench Pro, the hardest coding benchmark in existence. That's not just impressive, it's terrifying. While hitting that benchmark, Claude discovered a 27-year-old security bug hiding in OpenBSD, one of the most secure operating systems ever built. If AI can find vulnerabilities that human experts missed for nearly 3 decades, here's the question that should keep every cybersecurity professional awake at night. Is any code truly secure anymore? For decades, finding bugs in code was like searching for needles in haystacks. Human security auditors would spend weeks combing through millions of lines, hoping to catch the vulnerabilities that hackers might exploit. Then, Anthropic's Claude Mythos hit 74% on SWE-Bench Pro, the gold standard for AI coding ability. Here's why that number just changed everything about cybersecurity. You wake up to 17 security alerts in your inbox. Your company's firewall caught 3 intrusion attempts overnight, your password manager flagged suspicious logins, and somewhere in Silicon Valley, an AI just scanned your entire code base while you slept. Here's what Claude Mythos can do in the time it takes you to grab coffee. It reads through millions of lines of code, identifies potential vulnerabilities, cross-references them against known attack patterns, and generates a detailed security report, the same task that used to take a team of security experts weeks. Your security team used to manually audit code like archaeologists, carefully brushing dirt off each function, each variable declaration. Now they're staring at screens that refresh faster than they can read, watching AI systems find bugs in legacy code that's older than some of their junior developers. The gap is staggering. Traditional security audits catch obvious flaws, the low-hanging fruit that any experienced developer would spot. But AI systems like Claude Mythos, hitting that benchmark score of 74%, they're finding the needles in haystacks, the subtle logic errors buried in decades-old code. You're debugging a payment system at 2 in the morning, triple-checking every input validation, every boundary condition. Meanwhile, somewhere else, an AI has already found the buffer overflow you missed, the one hiding in a library function that hasn't been touched since the late 90s. The math is simple, we're not keeping up, but here's the dark side nobody talks about. That same AI that scored 74% on SWE-Bench Pro, it can hallucinate with complete confidence, missing critical security flaws while flagging harmless code as dangerous. You're looking at a system that's brilliant enough to find a 27-year-old OpenBSD bug, but might confidently tell you your perfectly secure login system is vulnerable because it doesn't recognize a newer authentication pattern. The villain here is confident hallucination, and it cuts both ways. On one side, you get false positives, where AI flags secure code as vulnerable, sending your security team down rabbit holes chasing ghosts. On the other side, you get false negatives, where real vulnerabilities slip through because the AI confidently declares them safe. Both scenarios waste time, but false negatives can be catastrophic. Here's where it gets worse. We're entering an arms race where malicious actors are using the same AI capabilities to find and exploit vulnerabilities faster than defenders can patch them. The Anthropic paper that showed Claude Mythos hitting 74% on coding benchmarks? That same reasoning ability works just as well for attackers scanning your infrastructure for weaknesses. Picture this cycle spinning faster and faster. AI discovers vulnerabilities, patches get deployed, new AI models get better at finding different types of flaws, attackers adapt their AI tools, and the whole cycle accelerates. You're not just defending against human hackers anymore, you're defending against AI that can analyze your entire code base in minutes and reason about attack vectors you haven't even considered. Here's how that 74% actually works. SWE-Bench Pro gives Claude 2,294 real GitHub issues from major Python repositories like Django and Flask. Each issue is a genuine bug report or feature request that human developers already solved. Claude gets the repository state before the fix, reads the issue description, and has to generate the exact code changes that match the human solution. The scoring is binary, pass or fail. Claude either produces code that passes all the same tests the original human fix passed, or it doesn't. No partial credit, no style points. Out of those 2,294 challenges, Claude Mythos solved 1,698 correctly. That's where the 74% comes from, 1,698 divided by 2,294. But here's the kicker. Claude isn't just memorizing solutions, it's recognizing patterns across millions of lines of code, spotting the subtle relationships between function calls, variable scopes, and edge cases that human developers miss. When it found that 27-year-old OpenBSD bug, it was analyzing memory allocation patterns in C code, tracing how a specific function could overflow under rare conditions. The difference is scale and consistency. A human reviewer might catch obvious bugs during a focused session, but they get tired, they miss context, they have deadlines. Claude processes every line with the same methodical attention, cross-referencing against patterns from thousands of similar codebases. It doesn't get distracted or assume the previous developer got it right. But here's the catch. Even if Claude Mythos audits every line of code on Earth, it can't fix the human sitting at the keyboard. You click the phishing email, you reuse passwords, you plug in the USB drive you found in the parking lot. Perfect code auditing solves technical vulnerabilities, but cybersecurity has always been a people problem. Social engineering attacks don't exploit buffer overflows, they exploit trust. The hacker doesn't need to find a bug in your authentication system when they can just call your help desk pretending to be you. You're not behind if this feels overwhelming. Most security breaches happen because someone with legitimate access either makes a mistake or decides to cause harm. That insider threat, that moment of human error, that's the gap where freedom lives for attackers. Claude can audit a million lines of code, but it can't audit the intentions in your heart. That 74% isn't a ceiling, it's the new floor. Security isn't about building perfect walls anymore, it's about how fast you can adapt when those walls get climbed. The game changed, and the winners will be the ones who change with it. Your security is only as strong as your ability to evolve faster than the threats hunting you. The gap between what AI can find and how quickly you can respond is where your safety lives. If this shifted how you see cybersecurity, subscribe to the channel and turn on notifications. Thanks for watching, and I'll see you in the next one.